revolutionary physicist who performed nuclear fission for the first time without even realizing it. Born on the 29th of September 1901 in Rome, Italy, his father, Alberto, was chief inspector of the government railways, and his mother, Ida, was a schoolteacher. At only 17, he received a scholarship for the distinguished Scuola Normale Superiore program at the University of Pisa, founded by Napoleon himself. He received his PhD in only 4 years and received fellowships to travel to Germany's University of Göttingen. Here, he studied under Max Born before using another fellowship to study with Paul Ehrenfest at the State University of Leiden in the Netherlands. Only 2 years later, at 23, he returned to Italy at the University of Florence, not as a student, but as a lecturer in mathematical physics. He researched general relativity, statistical mechanics, and quantum mechanics. From 1926 to 7, he worked on a new branch of statistics, Fermi direct statistics, to explain unusual behaviors of subatomic particles. A class of particles was later named after him, fermions. Fermi started gathering a group of professors to research with, who, due to his energy and seemingly infallible nature, dubbed Fermi the Pope. In 1929, Enrico was given a position of high honor by the Prime Minister of Italy, Benito Mussolini, due to his being the first professor of theoretical physics in Italy. As the field of quantum mechanics became more saturated, Enrico shifted his focus to the newer study of nuclear physics. There was confusion about a type of radioactive decay called beta decay, which Enrico reasoned could be explained by the inclusion of a hypothetical particle called the neutrino. After Marie Curie's daughter Irene and her husband Frederick discovered artificial radioactivity in 1933, Fermi started theorizing even more possibilities. He and his team started bombarding various elements with rays of neutrons, hoping to induce this artificial decay that would change the element of the target. Eventually, he bombarded uranium, the heaviest known element, with the newly discovered particle neutrons, and he ended up with a radioactive lump matching no known isotope. Fermi had done the impossible. Enrico Fermi had created a new element. Or had he? Several years passed. Tensions grew in Europe as it neared the outbreak of World War II. Unfortunately, Italy was allied with Germany, and Fermi's wife Laura was Jewish. On the exact same day that Italy imposed the anti-Semitic policy of Germany, Enrico Fermi receives a phone call telling him he has won the 1938 Nobel Prize in Physics. It was the perfect excuse for him and his family to flee to Sweden, where they attended the Nobel Prize ceremony and later settled in the USA. Enrico's story, however, does not end here. Far from it. After having only been in America for 2 weeks, exemplary Danish physicist Niels Bohr brought the news. Fermi had not created a new element. He had performed nuclear fission for the very first time without even realizing it. He literally split uranium atoms into 2 isotopes never seen before. This was groundbreaking. See, when uranium atoms split, a few sole neutrons split off, like crumbs when you rip a piece of bread. Scientists immediately realized that if these neutrons could be directed into other uranium nuclei, much like the first one, they would undergo this same decay. This could spark a chain reaction where nuclei split, releasing neutrons that would spray out and cause other nuclei to split, etc. This would result in a clean, reliable, and stable source of energy, meaning the world's first nuclear plants could be built. However, a second, more horrifying possibility soon shook the world. If enough uranium atoms of an unstable nature were packed tightly together, the reaction would occur throughout all the atoms almost instantaneously, producing a much greater output of lethal energy. This reaction soon became known as a nuclear explosion, released by an atomic bomb. Fermi worked alongside Hungarian-born Leo Szilard to determine the exact requirements for such a nuclear reactor. He also wrote to and visited the government to warn them of the danger of an atomic bomb. However, they barely, if at all, took any heed to his words. It wasn't until Albert Einstein himself wrote to President Franklin D. Roosevelt in 1939 that the USA government finally took notice. Over the next 2 years, Enrico developed large structures made of uranium blocks surrounded by radiation-absorbent graphite ones. He then moved to the University of Chicago, where he continued to develop his piles under a football field. The first pile went critical near the end of 1942 and proved the feasibility of a proper nuclear reactor. In 1944, he moved to the newly founded Los Alamos, since he had received American citizenship. He was present for the detonation of the first plutonium bomb in mid-1945. After World War II ended, Fermi took up a permanent position at the University of Chicago. He again led a team of outstanding scientists into an even deeper field: elementary particle physics. By 1949, the Soviets had replicated the nuclear bomb, and America wanted to develop hydrogen bombs, always wanting to have more power than their enemy. Enrico, as an advisor with the General Advisory Committee, along with Isidore Rabi, warned President Truman that such a bomb becomes a weapon in which practical effort is almost one of genocide. It is necessarily an evil thing considered in any light. Unfortunately, they were unsuccessful, and Enrico soon found himself back at Los Alamos, overseeing the development of a hydrogen bomb. Eventually, they found that it was simply not possible with their current technology, and life returned to normal for Enrico. In the 1950s, Enrico conducted pioneering research on both pions and muons. He wrote extensively on many mysteries surrounding deep space. Unfortunately, though, working so close to Oakland nuclear pulse proved fatal for Enrico, and he died on the 28th of November 1954. Enrico received multiple awards throughout his life. He received the Matteucci Medal, the Nobel Prize in Physics, the Hughes Medal, the Franklin Medal, the Rumford Prize, and the Medal for Merit. He was a member of both the American Philosophical Society and the foreign member of the Royal Society. Countless institutions, locales, awards, facilities, and more have been named in his honor. When further transuranic elements were synthesized, element 100 was named in his honor: Fermium. The Fermi Lab Particle Accelerator and Physics Lab in Illinois, the Fermi Gamma Ray Telescope, 3 nuclear reactors, 1 research reactor, the United States Atomic Energy Commission's and U.S. Energy Department's highest medal, the Fermi Award, a class of subatomic particles, as mentioned earlier, a unit of length equal to a femtometer, and countless others have all been named in his honor. Enrico Fermi, one of Italy's and America's best scientists, was truly the best physicist of the 19th century. Hey guys, thanks for watching. Hope you enjoyed this video. Sorry I didn't get this uploaded for a while, but it's been super fun to make. If you enjoyed, make sure to subscribe, like, and comment down below, and I'll see you guys in the next video. Peace!